Hello, stats class. This last set of notes is optional because basically a couple of years ago, people asked, could we do one more example on the review day? And so here it is. Here's the one more example if you need it. And if you don't need it, that's fine too. So it was based on an AP Stats pair of students doing a project. And they went to the store and tried to determine whether the express lane at the grocery store was faster than the regular lane. They randomly selected some times. They flipped a coin to see which of the two people would go to the express lane and versus the regular lane, and calculated or timed how long it took to get through the line. And so I'm not going to write the data as part of this. I'm going to show you the data, and if you'd like to pause the video and write this down, you can, or you could just watch. There's the official example here's the information about how they did it, and then here's the express lane times and the regular lane times, and I'm going to go straight to doing the problem, but if you'd like to do it with me, you can. So step one, our null hypothesis is that the mean difference between express lane and regular is 0. The alternate depends on which way we decide to subtract. So let's think about this. Mu d is the mean difference in times. I want to point out that this is definitely matched pairs because the two of them went to the store at the same time and both stood in line at the same time. So those are a matched pair. Each pair of numbers is matched up based on that. And I think because last time I did a greater than, I'm going to plan it so that this time is a less than. Less than, I think that the express lane is going to take less time, and so I'm going to choose less than, and I'm going to subtract express lanes minus regular. And it's really your choice which way you do it. If you decide to subtract regular minus express, that's fine, then you'd have a less than. And by the way, I'm doing alpha equals 0.05. Let's not forget that detail. Because I chose this direction, I'm going to do list 1 minus list 2 on my calculator to get my differences. And I have not done that yet. Here's the data that I typed in before I started the video. And I'm doing list 1 minus list 2. And some of them are negative, some of them are positive. Negative is good because it means that I was right, that the express lane did take less time. And anything that's positive, which there aren't very many of them, are times when the person in the regular lane got through faster. All right, step 2. We're going to do a matched pairs t-test. You can leave off the mean differences if you want to. Random. Yes, they selected random times, and also they flipped a coin. I forgot to write that up above. So I guess here's an example of an experiment, or not an experiment, but a random sample of times that still matched pairs. Normal. Okay, I didn't tell you this yet, but n is 15. So we need to graph it. And I have not graphed it yet. So here's a reminder of how to graph. I'm going to actually go to second y equals and turn on plot 1. Actually, I really like the normal probability plot best. I'm going to just use that. Normal probability plot of list 3, which is my differences list. And I'm going to look at that plot by doing zoom 9. And it's pretty straight. So normal probability plot looks like this. One outlier, but it's pretty straight, and so that means yes. Approximately linear. So yes, we can say it's normal. Independent. Also yes, because 15 is definitely less than 10% of all the times they could have chosen. This time I am checking the 10% because it's not an experiment, it's a sample of times. I think they did this over the course of a week, and so yeah, at all times they could have chosen in 1 week. All right, so the conditions are met. Yay. Step 3, here's a reminder of the do step. We're going to find t by doing x bar d minus 0 over sd over square root of n. Notice this is the same formula as before, except we put some d's and we put a 0 instead of a number. But the 0 came from here. So x bar d I need to actually find by doing stat calc, one variable stats list 3. X bar is negative 42.666, which bothers me because last time I didn't get that. Hang on, I got to check my work real quick. Oh, I did it wrong last time. That's so sad. All right, so negative 42.6 minus 0. Standard deviation is 84.02 over square root of n, which is 15. And since I did it wrong last time, I'm going to do it right this time. Oh my goodness. So I'm going to do negative 42.6, let's round it to 67, divided by 84.02 divided by square root of 15. And I got negative 1.967 as my t-score. Looks like we're probably not going to reject, but I won't know for sure until I find the p-value. That's really close, so maybe we will. We'll see. So then I'm going to do a t-CDF of, this time it's a less than, so I need to do negative 999 and negative 1.967, and our DF is 15 minus 1, which is 14. So I did get a low enough one to reject. It's hard to predict with t for some reason. And remember that you could also do it with the t-test and the data option, and make sure you choose less than, because otherwise it'll go the wrong way for your p-value. That should be the same p-value that I just got. Yep. And last but not least, let's write a conclusion. I guess I didn't put the word state on here, and I didn't put the word plan. If that helps you write it, you don't actually have to write it. Since p is 0.035, which is less than 0.05, we can reject the null that there's no difference. I like writing it that way, actually, because it emphasizes the fact that the null is the boring one. The null is there's no difference between time times for the express lane and the regular lane at the grocery store. And we conclude, let's make sure we know, we said less than because we thought that the express lanes would be smaller than the regular, and it turned out they were. So we conclude the express lane is actually faster on average. It doesn't mean it's faster every single time, because some of our values did come out positive, but overall, the average is faster. So there's your one more example if you needed it. And I kept it kind of short. If I went too fast, you're welcome to go back and rewind and pause and whatever you need to do. And there is highly likely to be one of these on the quiz. What do you know? I don't want to promise that, but you never know. All right, that's it for this optional notes.